Why we believe the Earth rotates, not the sun. When you stand outside and watch the sky, it feels obvious. The sun rises in the east, climbs above us, and then sinks into the west. From our perspective, it looks like the sun is moving across the heavens. So here's the question: why do we believe the opposite? Why do scientists insist that it's the Earth spinning, not the sun? This is the story of how our understanding of the cosmos flipped upside down. It's about the evidence, the controversy, and the slow journey from a world where humans thought they stood at the center of everything, to one where we orbit just another star in an endless universe. For most of human history, people trusted what they could see, and what they saw was the sun crossing the sky. Ancient Egyptians built temples aligned to the sun's path. Babylonians tracked its movements to create calendars. The Greeks, brilliant thinkers like Aristotle, concluded that the Earth was fixed in place, with the heavens revolving around it. This idea was refined by Claudius Ptolemy, a Roman-era scholar. He designed a geocentric model, Earth in the middle, with the sun, moon, and planets circling it on perfect spheres. For centuries, this model ruled science, philosophy, and religion. Why? Because it matched human experience. Stand in a field, and you'll see the sky turning above you. You don't feel the Earth moving. To people then, the geocentric model wasn't just logical, it was obvious. But not everyone agreed. In the 3rd century BCE, a Greek thinker named Aristarchus of Samos suggested something radical. Maybe it is the Earth that moves around the sun. His idea, however, was dismissed. It felt too strange, too different from daily experience. It wasn't until Nicholas Copernicus in the 1500s that the heliocentric model resurfaced with force. Copernicus argued, the Earth spins on its axis once every day. The Earth also orbits the sun once every year. This explained the sun's daily movement, the seasons, and even why planets sometimes appear to move backward in the sky. But Copernicus's theory was dangerous. It challenged both tradition and religion. For centuries, the Church had taught that Earth was the center of God's creation. To suggest otherwise was not just science, it was heresy. Then came Galileo Galilei. In 1609, he turned a telescope to the sky and saw things no one had ever seen. He saw craters and mountains on the moon, proof that celestial bodies weren't perfect spheres. He saw the 4 largest moons of Jupiter, orbiting not the Earth but Jupiter itself. And he watched Venus go through phases, just like the moon, something that could only be explained if Venus revolved around the sun. Galileo declared the heliocentric model correct, but his boldness earned him enemies. In 1633, he was tried by the Inquisition and forced to publicly recant his ideas. Still, the evidence was out there, and the world was beginning to shift. For centuries, heliocentrism was a theory. But how could we prove the Earth was actually rotating? In 1851, a French scientist named Léon Foucault provided a breathtaking demonstration. He set up a huge pendulum in the Pantheon in Paris. The pendulum swung back and forth in a straight line, but over time that line appeared to rotate. The Earth was moving beneath it. This was simple, direct proof of Earth's rotation. There were other clues too. The Coriolis effect, storms spinning clockwise in one hemisphere and counterclockwise in the other. That only makes sense if Earth rotates. The day-night cycle, sunrise and sunset, explained not by a moving sun but by a spinning planet turning toward and away from its star. And with modern science, the evidence multiplied. Satellites, space travel, time-lapse photography, all show Earth turning majestically in space. So why did humanity cling to the idea of a moving sun for so long? Partly it's our senses. We don't feel motion. Sitting on Earth, we're moving at over 1,600 kilometers per hour at the equator, yet it feels still. Just like passengers on a smooth airplane don't feel the plane's speed unless they look out the window. It was also cultural and religious. To say the Earth wasn't the center of the universe was to say humanity wasn't the center either. That was a difficult truth to accept. Galileo's trial was as much about faith and authority as it was about science. In the end, it took centuries of observation, courage, and proof to change minds. Today we take Earth's rotation for granted. We design satellites, GPS systems, and even weather predictions around it. Astronauts on the International Space Station see it with their own eyes, a spinning globe turning steadily beneath them. What was once unthinkable is now everyday knowledge, and it's a reminder. Sometimes the truth isn't what our senses tell us. Sometimes reality requires imagination, evidence, and the willingness to question what feels obvious. So the next time you see the sun rising, remember this. It isn't the sun moving across the sky. It's you and the entire Earth spinning into the light of day. The journey from a geocentric universe to a rotating Earth didn't just change astronomy. It changed our perspective of ourselves. We're not the center. We're part of something larger. And the search for truth is what keeps us moving forward.